Welcome everyone. My name is John. I worked alongside Devin and Dean in this team project where we used Excel VBA to do a simulation of Abbott's manufacturing lines. So the goal or aim of this project is to build a model to simulate the Abbott facility. So this will verify and validate the model and analyze the results. For the purpose of analyzing the performance of the system, we will calculate the average minimum maximum queue length of each workstation, the average minimum and maximum waiting time in each queue, the average throughput, the average number of defects in each workstation, and the total amount of scrap. For our project, we have the following requirements. We're to have a welcome page, a simulation model user form with distribution in a combo box and batch size, frame where the user can pick a workstation and distribution where values can be saved, frame with probability of defective items with rework and scrap for each workstation, 3 text box with number of iteration, length of the iterations, and a warm-up period, an animation box that displays graphs and a command button that submits the information, as well as a summary of the results sheet that displays important information on wait times and query times. We will now demonstrate our simulation through a live demonstration in Excel. Alright, so for the live demonstration, we have opened the Excel file and we are now prompted with the welcome user form. I'm going to select start, and now we have the simulation model. So we're going to start with the inner arrival time, where we're going to select a distribution and then enter some parameters for that distribution. So I'm going to start with the normal distribution. We'll say a batch size of 250. Go over here and say 50 for the mean, and a standard deviation of 5. We're going to save these parameter values, and then we have a message box that prompts us with the confirmation that the center arrival time has been saved. Next, we're going to the processing time at each workstation, and I'm just going to show you each one. For example, let's do filler with the normal distribution. We'll say the mean is 50, standard deviation of 5. This is saved. Go to the accumulator. We'll do uniform distribution. Do a min of 45 for the minimum and a maximum of 70. We're going to save that value. That processing time has been saved as well. Capper, we'll just do the Poisson distribution. And we will do a mean of, let's just say 62. Save that. And the case packer we'll do with binomial. We'll just say 90 trials with a probability of 70. Save that. So for error checking, I entered in 70, and it should be 0.70. Now on to the probability of defective items. We're going to do some error checking first. I'm going to just do a correct one, and I'm going to put some letters in here, and then I'm going to put a negative in here. I'm going to go to save it, and as you'll see, it tells you to enter a valid value, and it has erased the ones that were incorrect in workstations 2 and 3, but it has kept the correct one available. So now I'm going to actually enter in some actual values. So we'll do 5% here, we'll do 8%, 7, 11. Yeah, because rework and scrap costs are usually pretty low, so I like to keep the percentages low as well, just to be accurate. Do 5 again. 7, and let's go with 9. So I'm going to save these, and now the probability of scrap and rework have been saved. So now, let's come on down to the total number of iterations. We're going to enter in, we'll just say 15, we'll say a length of 10, and then a length of warm-up of, we'll just say 2. Okay, so once all this information has been entered, we're going to now go over to run simulation and display the summary results. And click OK, and then OK. And here we have our two charts of the normal enter arrival time and the Poisson processing. We're now going to go to the summary page by clicking to summary. And then we have our queue length, we have the average queue time, the average products in the queue. We got our general information such as server utilization, time in system, average product in the system, average time in the system, and then probability that the system is empty. Throughput, scrap, and defects. We have an average throughput of 2 here. Number of defects, we'll say is 30. 40 for the number of scrapped items. And then right over here, we have the starting batch arrival to the last batch in the system, where the time starts at 0 and it just continues to increase.
All right, so I'm going to start going into the code of this simulation. So you go into the simulation button, and starting from the top, you have all the parameters that are called upon. And all these are just showing what parameters you want to make visible. So if you clicked on the normal or if you clicked on Poisson, it just make those visible for the user to see. So these are error checking. So just making everything yellow if there's the wrong things entered into those boxes. Going down, same thing for this is more error checking for the Poisson distribution, for the normal distribution, all those error checks, and then showing what parameters you want to show. Where it says button that runs the simulation code, this is the main code that we were looking at. So these output the parameters to the sheet, and this is a little bit of error checking. Farther down we go, we see the chart variables that are DM'd, and then we scroll down, it picks what case that we decide, the user decides, so binomial, Poisson distribution, and normal distribution. Depending on which one you pick, it will output a sheet that will have those values in there. So if you pick normal distribution, it will have a randomized sheet with those values. And then they have these loops right down here that pretty much just loops that sheet that was made over and over again until it's chosen the batch number that the user chose. And there's also a loop to keep track of the time, so you can look at stuff like inner arrival time and the amount of time it takes from the piece getting started in the batch all the way to the end of the batch. Right here is where it makes the chart. This is actually super cool because it takes in the data to make the chart from what the user chose to put in and grabs it from the folders that you specify. So it has to be put in for each different person's computer. So and then it'll update that chart in the picture, and then that will update in the module. The processing distribution that DMs an array, creates the array that holds all the parameters and values. This goes from 1 to 4 because we have the 4 different kinds of distributions. This is a bunch of error checking to make sure that everything is entered in correctly. If not, the messages will pop up. This shows the average processing time. That's on that last sheet that's outputted. Chart creation. This will change the chart based on what the user decides to change. And that just enters in the chart name. Then we have the chart series collection new series. So those are all the changes made too, different for user form. Here's that arrival chart that you saw in that very last form that was made. That pretty much shows when something entered the batch to when it exited the batch. See the time. Then we just go to calculations for the summary form. This is all those outputted calculations that you saw. That's all saved to a sheet. So these pull the values from that sheet. And then these are pretty much just hiding and showing different